The concept of an automatically shifting transmission is almost as old as the car. Many early drivers had difficulty operating manual transmissions. Synchromesh manual gearboxes weren't introduced until 1928, and as a result, the early history of the automobile echoed with the grind of clashing gears. In addition to having numerous durability and drivability problems, early automatic transmissions were heavy and costly. Work began in earnest in the mid-1920s when Alfred P. Sloan Jr., then a General Motors vice president and director, suggested that an automatic transmission would be required to make driving easier for everyone. Feasibility studies at GM's Dynamics department resulted in further development at Buick, who became a key player in the quest for an automatic transmission. In 1937, Buick began building a transmission called the self-shifter for Oldsmobile. Buick built about 3,000 cars with the self-shifter for model year 1938, but dropped the option for 1939. The self-shifter, although a precursor of the hydromatic transmission, was not a success. What it needed was a torque converter. Torque converters were developed for the Buick Hellcat tank destroyers in World War II. After the war ended, a torque converter for automotive applications was built. This resulted in the Dynaflow transmission, first offered by Buick for model year 1948. The Dynaflow was enormously successful. By 1954, 85% of all Buicks had a Dynaflow transmission. In the early days, automatic transmissions were regarded as high technology. Minute machining tolerances and a sensitivity to heat, dirt, contamination, and mishandling made automatic transmissions off-limits for most do-it-yourselfers. Even today, nearly 50 years later, not much has changed. You still need special knowledge and tools to diagnose and repair automatic transmissions. Hello, I'm Chuck McLennan. In this edition of Buick Know-How, we're going to talk about service issues for the 4T60E and the 4T65-E Transaxles. We'll cover the major differences between the units. Then we'll review some procedures for transaxle fault diagnosis and CERTA replacement. And direct from the Buick Technical Assistance Center case files, we've got some specific drivability and noise concerns to tell you about. We'll start out with a comparison of the 4T60E and the 4T65E. As their model numbers indicate, they're both 4-speed transversely mounted electronically controlled transaxles. Both use 2 planetary gear sets, 4 multiple disc clutches, 2 roller clutches, 1 sprag clutch, and 3 bands. Both transaxles use the same power flow through the various gear ranges. However, the 4T65E contains numerous improvements to increase load capacity, reduce noise, and improve drivability and fuel economy. You can see the overall difference in this cutaway. The blue paint indicates that a change was made to the component from the original 4T60E design. Here are a few highlights. For load capacity, the inside diameter of the second clutch assembly was increased to accommodate larger clutch discs. The reverse reaction drum and input carrier have larger and stronger splines. The 4T65E is a quieter transaxle due to the redesigned drive link assembly and oil pump. The 4T65E uses 2 chains instead of 1, and the sprocket teeth are 180 degrees out of phase. This causes the sound waves generated by the chains to cancel. Both sprockets are now forged from powdered metal for quieter operation. Cast metal sprockets have a tendency to ring. The oil pump in the 4T65E has more vanes for increased oil flow. The vanes are also randomly spaced for quieter operation. Perhaps the biggest difference between the two units is the way that line pressure is controlled. In the 4T60E, line pressure is controlled by the vacuum modulator. In the 4T65E, line pressure is controlled by the PCM and a pulse width modulated pressure control valve. This arrangement, with the addition of a transmission input speed sensor, allows the timing and duration of each shift to be measured and controlled. For example, as clutch packs wear, more time is needed to apply the clutch. The PCM calculates what is known as a shift adapt by checking the reaction time of the input shaft with each shift. The PCM compensates by increasing the line pressure to maintain clutch apply time. This automatic wear compensation results in a transaxle that shifts just like new, even after 100,000 miles of service. Shift adapt information can be obtained with the Tech 2 to provide valuable diagnosis information. Programmable electronic shift control also allows similar transmissions to be used on a variety of platforms. This helps decrease the number of production variants. Currently, 2 versions of the 4T65E are being produced. The normal duty version is installed with a 3.8-liter normally aspirated power plant, and the heavy duty version is installed with the supercharged 3.8-liter engine. A 3rd version is in the planning stages for use with the 3.1-liter V6. The heavy-duty version has a slightly longer output shaft and a 258-millimeter torque converter. The normal-duty torque converter diameter is 245 millimeters. Both converters use the EC3 system to reduce chuggle. The EC3 system allows the converter clutch to slip slowly by varying the lockup clutch apply pressure. Now, let's move on to transaxle diagnosis. It begins with the initial customer contact. In addition to a description of the symptom, you'll need 3 more pieces of information to write a good complaint. First, find out if the customer notices the problem every time they drive, or whether the problem shows up intermittently. Second, find out if the symptom occurs when accelerating, at any speed, decelerating, braking, turning, or idling. If necessary, take a road test with the customer so that they can demonstrate the symptom. Third, find out if the problem happens when the engine is cold, warm, or at any temperature in between. The point of getting the information is so that technicians can duplicate symptoms easily. Then, give the engine a quick visual inspection. If the PCM has any current or history codes, capture the data with the Tech 2 so that you can duplicate the conditions under which the code was stored. Check for loose or damaged wiring or broken vacuum connections, and make sure the engine idles smoothly and responds to the throttle. It's possible for an engine fault to show up as a transaxle symptom. Then, check and adjust the transaxle fluid for proper level, color, and condition. Don't road test the car if the fluid smells burnt or the fluid is milky from coolant contamination. You need to get the powertrain into failure mode, so don't clear any codes or make any further adjustment until after you have verified the complaint. If you've never worked on a car with a similar complaint, it's a good idea to review any transaxle service bulletins, along with service manual diagnostic charts that pertain to the complaint on the repair order. The first test is called the garage shift procedure. If you check the PCM for codes during the visual inspection, you're ready to do the test now. The garage shift test will tell you if the electronic control inputs are functioning. Start the engine and select the transmission data display on the Tech 2. Verify that the 13 signals listed on your reference card are present. Make sure that the brake switch input responds when the brake is depressed. Then, hold the brake and move the selector lever to each of the gear ranges. Each range should engage quickly and smoothly. Finally, select neutral and check that the throttle position angle changes when you depress the accelerator. The next step is the functional test. During the test, keep in mind that a good way to find out what's wrong with the transaxle is to first eliminate everything that's right with the transaxle. For example, you can substitute the Tech 2 for the PCM to see if the PCM is doing its job. Since procedures may vary from one transaxle to the next, take along the service manual for the unit in the car. It's also a good idea to have someone else do the driving while you call out the procedures and monitor the scan tool and the pressure gauge, particularly in heavily populated areas. Put the scan tool in snapshot mode when you get to the part of the road test that includes the customer concern. Also, write down the line pressure at shift points, the transaxle temperature, and the pressure when the TCC applies. The next test is the line pressure check. The line pressure test for the 4T65E is done by adjusting the current on the pressure control solenoid valve with the scan tool. Make sure that the transaxle fluid level is correct for this test. To avoid internal damage to the transaxle, do not run the test for more than 2 minutes. Increasing the current lowers the pressure, and decreasing the current increases the pressure. Check the pressures against the chart on your reference card. By now, the transaxle should have either failed the test or repeated the symptom, and you should have a good idea of whether the fault is electrical, hydraulic, or mechanical. On-vehicle service for the 4T65E Transaxle is limited to replacement of a few parts that are outlined in Service Bulletin 6771-58R. As a result, many 4T65E concerns have been resolved by CERTA installations. Even for an older transaxle like the 4T60E, though all replacement parts are available, a CERTA installation is indicated when damage is extensive or the cost of repairs exceeds the cost of the CERTA. When installing a CERTA, it's important to make sure that the feedback form is properly filled out and returned with the core. The CERTA program is a customer satisfaction-driven system that provides factory reconditioned and tested transaxle assemblies, and in return provides failed transaxle cores back to GM powertrain for analysis. To give you some help with transaxle diagnosis, the Buick Technical Assistance staff has put together some of the most common service issues for the 4T60E and the 4T65E. Issue number 1 concerns the 4T60E. It shows up as a whining noise in Park Avenues and LeSabres between 20 and 40 miles per hour. How you fix it will largely depend on the model year of the particular car. If the car is a 1996 model, the final drive can be replaced by itself. A separate gasket kit is required to complete the job. You may also have to replace the vehicle speed sensor reluctor wheel, which is pressed onto the carrier. The wheel may break or distort during removal. Try heating the reluctor wheel slightly with a propane torch before attempting to remove it. But if it doesn't want to come off, obtain a new part. Some reluctor wheels will not come off, even when heated cherry red. Replacing the final drive will result in a slight change in the final drive ratio, from 2.84 to 1 to 2.86 to 1. For 1994 and 1995 models, a CERTA is available with the updated final drive with additional updated components. The part numbers for both repair options are in your know-how reference guide. Service issue number 2 relates to shift quality. A customer may complain about experiencing harsh upshifts. Since it is the job of the accumulators to soften the shift, you need to start there. Look for broken or incorrect springs and make sure that the accumulators are properly assembled. Then check the accumulator valves for scoring, broken retainer clips, and make sure that the valve slides freely. Retainer clips are available separately, but if the valve is stuck, the valve body must be replaced. If it's okay, reinstall the valve and make sure that the retainer is in the proper location. The accumulator valve is inside this bushing. Some customers may comment about a mild bucking or jerking sensation at lower steady speeds, similar to towing a trailer. This is called chuggle, and it's the topic for service issue number 3. Chuggle is usually noticed while the torque converter clutch is engaged. This causes the engine to be mechanically coupled to the drive wheels. The limited drivetrain flex of front-engine, front-wheel drive vehicles causes more noticeable reactions during engine loading and unloading. Chuggle is more noticeable at lower speeds. If the PCM waits until higher speeds are reached before engaging the torque converter clutch, most drivers will not notice chuggle. Depending on the year and model of the car, the TCC engagement speed can be increased to reduce chuggle by either reflashing or replacing the memcal prom inside the PCM. If the new PCM calibration does not satisfy the customer, certain cars can be improved by installing a new torque converter with a viscous coupling on the TCC. The PCM must be calibrated a second time for the new torque converter when it's installed. The viscous coupling allows a small amount of slippage all of the time. The viscous converter should only be installed in extreme circumstances because it raises transaxle operating temperatures and reduces fuel economy. You must call Buick Technical Assistance to obtain the viscous clutch part number. Issue number 4 is for a shudder complaint between the first and second gear with light throttle. There are 3 separate components which may cause this concern. The first place to check is the 1-2 accumulator housing. The inside of the housing may have a rough or scaly finish. This was caused by a machining bit that left a degradable surface. Inspect the piston center hole and pin of the 1-2 accumulator assembly for pitting and scoring, and check the accumulator piston seal for cuts. Make sure the correct springs are installed and that the accumulator is assembled properly. The second place to inspect is the valve body. Remove the 1-2 accumulator valve. If you find any debris or scoring on the valve or inside the bore, replace the valve body. If it's okay, make sure that the valve bushing and retainer clip are properly installed. Next, check the 1-2 shift valve for pitting and scoring. If you don't find anything wrong in the accumulator or the valve body, you need to get inside and look at the second clutch pack. You may find an uneven wear pattern on the steel plates, or in other cases, the steel plates may be warped. To check for warp, lay the steel plates on a flat surface and check the inner and outer edges with a 1/1000th of an inch feeler gauge. If a gauge can be inserted under any of the plates, replace the entire clutch pack. See your know-how reference guide for the part numbers. The new steel plates will be slightly thicker than the originals, and the fiber plates will be slightly thinner. The wave plate doesn't need to be replaced unless it's damaged. Issue number 5 shows up by intermittently lighting up the service vehicle soon indicator and storing DTC P1870 in the PCM in 1996 vehicles. The light usually comes on after 15 to 20 minutes of operation. A P1870 tells you that a transaxle component is slipping. Although the condition can be traced back to one or more of several components, the most commonly found cause is that the lockup clutch inside the torque converter is slipping due to excessive clearance in the clutch apply valve. To repair it, the valve body must be replaced. A customer may comment that the transaxle periodically loses drive or goes into uncommanded neutral. These intermittent neutral concerns usually happen either at highway speeds or when taking off from a stop. The uncommanded neutral at highway speed concern was addressed with Service Bulletin 677164, but the problem is still generating a number of calls to Buick Technical Assistance. This problem is caused by a sticking 2-3 shift valve. See the Service Bulletin for complete procedures. The intermittent neutral at takeoff problem has almost stopped generating calls. This problem was caused by a faulty input clutch piston seal rolling. A customer may comment that the transaxle upshifts too quickly or that it doesn't downshift quickly enough. They may feel a shuddering vibration at low speeds during acceleration or deceleration. This is issue number 7, second gear torque converter clutch engagement. The shudder that's occurring is engine lug. Second clutch fluid also feeds the converter clutch valve, so it's logical to assume that the TCC valve is being forced to the on position. When you remove the solenoid, you might find some debris behind it. It's natural to think that this debris is plugging the valve exhaust and causing second clutch fluid to push the valve to the on position. But the problem may be upstream of the valve. The debris inside the valve could be fragments of the converter clutch orifice screen or the O-ring. The screen reduces second clutch fluid pressure to the TCC valve. If the screen is loose, missing, or damaged, the high pressure will back up behind the TCC valve exhaust, causing the valve to open whenever the second clutch is applied. To fix this problem, you need to replace the orifice screen and the O-ring in the channel plate. See your know-how guide for the part numbers and procedures. Some intermittent problems with the 4T60E can be resolved with a flushing procedure. As a transaxle wears with normal use, small particles of metal and clutch material can accumulate in the hydraulic passages. The deposits can cause a wide variety of intermittent shifting problems, like delayed engagement, late shifts, and slow shifts. If the vehicle is never driven hard, engine vacuum remains relatively high and line pressure stays low. To perform the flush procedure, disconnect and plug the vacuum line to the vacuum modulator and road test the car with the scan tool. Drive the car using all of the ranges on the range selector and cycle the TCC with the scan tool several times. This will open and close every valve and subject all hydraulic components to maximum line pressure. The high pressure can do two things. It can clear the obstruction and make the intermittent symptom disappear. But it can also force the symptom to appear constantly by breaking a weakened part or permanently jamming a sticky valve. Any loose deposits will be picked up by the filter. You can follow up the flush procedure with a fluid and filter change if the mileage of the vehicle warrants it. We've got two service issues for the 4T65E. The first issue relates to a change that was made to correct a harsh garage shift that occurred when shifting to drive while still moving in reverse. See Service Bulletin 777160 for complete information. The second service issue is a whistling sound while idling, and it's also known to occur in the 4T60-E Transaxle. The noise has been traced to the drive link assembly. You need to replace both sprockets to fix it. The updated part numbers are in your know-how reference manual. It isn't easy to make a living as a service technician. If you've been in the business for a while, you've seen how cars have changed over the years. Keeping up with these changes takes a lot of effort. You need the latest tools and information. Now, most shops have no shortage of tool salesmen, but getting information can be challenging. A good place to start is the Service Technicians Society. The STS is affiliated with the Society of Automotive Engineers. Part of the STS mission is to advance skills and education, inspire professionalism, and foster communication and cooperation among service technicians in the mobility industry. When you join the STS, you'll get a bi-monthly newsletter, access to SAE and STS publications and educational programs, and member discounts on car rentals, hotel, travel, fax equipment, and a lot more. The STS has its own internet website with links to other automotive sites. You can find out more about the STS by calling 1-800-STS-9596. Another good way to increase your professional standing is by taking technician tests from the Institute of Automotive Service Excellence, or ASE. The ASE tests are tough, and most people learn a lot just by preparing for them. When you pass the tests, you'll join an elite group of technicians who take extra effort to assure customers that a knowledgeable technician is servicing their vehicle. We have one final note to pass on to you. Buick has revised the training standards for transmission and transaxle technicians. Rear-wheel drive classes are no longer required. Well, that about wraps it up for this edition of Buick Know-How. Good luck with the quiz, and we'll see you next month.